Hello everyone, welcome back to Geoshastram. Today we'll discuss some basic concepts of crystallography. So basically, what is a crystal? So here you can see this diagram. It shows one perfect crystal. So this I can call it as a crystal, right? What if I draw a small cube? Will it be a crystal? Yes, of course. This shape can also be a crystal. Why so? Because see here, this crystal and this crystal, they have a certain similarity. Look at this crystal. So here you have a well developed face. Yes, so this has a perfect shape. Even if you come here, this has a face, and it is also, yes, this is also what, perfectly developed crystal. Okay. So the crystal can be defined as, it's nothing but the outer expression. Yes, a crystal is a outer expression of well defined, well defined inner atomic structure. So when the inner atomic structure is well defined, so that time the crystal has a different shape, or it is well defined. Okay, so now moving on to the components of crystal. Okay, so components of crystals. So what are the components of crystals? First one, the crystal face. Yes, so what is a crystal face? If I draw a if I draw a cube, then this has face. Yes, this is a well-defined face, this is a well-defined face, you have here a well-defined face. Yes, so crystal face is nothing but the well defined outer surface. So here if you see, it is well defined, it is square, so it is well defined. If you see in this diagram also, so this is well defined, so we can call this as a crystal face. Even this is well defined, we can call this as a crystal face. Yes, second one, that is the crystal edge. Crystal edge is nothing but where two faces meet, sorry, where two faces meet, so that part is called the crystal edge. In case of here, in case if you see here, so this is one crystal face, and this is one more crystal face. Yes, so where they meet, they meet at this junction, so this is called the crystal edge. If you see in this diagram, so this is one face and this is one face, so this becomes the crystal edge or the edge of a crystal. So the third component is the solid angle. So what is a solid angle? Again, here where three faces meet, that point is called a solid angle. So in case of this diagram, so this is one face, and you have one more face which is here. So where these three faces meet, they meet at this point. So this point we can call it as a solid angle. In case of this diagram, yes, this is one face, and this is one more face. Okay, so they three meet at a point, so this is called a solid angle. Clear about what is crystal and the components of crystal. There are faces here. Yes, there is a face here, and there is a face here. There will be face below, beside this, and here you can see there are many faces. So basically, combination of faces are called forms. Okay, so in forms of crystal, it is basically divided into two types. One is the open form, and the other one is a closed form. So now, what is open form and what is closed form? So in open form, we usually call a mineral where the crystal surfaces are not developed, or the crystal is underdeveloped. Okay, so if I take a crystal which is underdeveloped, then we call this as a open form, or a crystal where only one face or two face is developed, so we call it a crystal with a open form. In case of closed form, if the crystal is completely developed, or closed with a well developed faces, then it is called a closed form. Okay, so now next we'll move on to the symmetry of crystal. Symmetry of crystal. So we all know that symmetry, that is symmetrical, when you when you have a piece of square cake, and if you want to divide it with 2%, so what you will do, you will cut it exactly half, yes, to share the equal amount. So that we call, what we call here, we are cutting the cake in a symmetry. Similarly, in crystal, yes, if a crystal can be cut into equal halves, then we call it as the crystal contains a symmetry. Yes, when A is equal to B, when it is cut into equal half. Okay, next, moving on to rotation of symmetry, or okay, so here in rotation of symmetry, if I take this, okay, this box, and consider this face. Okay, I have highlighted this face for the better understanding. So if I take this face and if I start to rotate it, okay, I will rotate in such a manner that I have to get this face again in the same position and in the same direction, and I will count the number of rotations, like how many rotations will it take for this face to come back to its same position. So I'll hold this in the faces. Okay, this is one face and this is one face. I'll hold it like this. I'll start to rotate it. This is the face. I'll rotate it. This is one more face. 1, 2, 3 and 4. The fourth time I am getting the same face in the same position, in the same direction. Okay, so this, when we rotate it 4 times, so here first, okay, if it is a open form, okay, if the crystal doesn't contain any face or it is underdeveloped, so here there is no face, so we can't rotate it, so here we call it there is no fold, no fold symmetry. Okay, so when it comes to square or a cube, okay, and I am holding it in along the faces and I am rotating it. So for every 90-degree I am getting a new face. See, this is the face, I am rotating it 90-degree, I am getting a new face. So for every 90-degree I am getting a new face, and this face comes back to its position when it is rotated 4 times, that is 4 fold symmetry. Clear? Now the third one. So I'll hold, for the third one I'll hold this box along the solid angles. So here if I rotate, so this is the face, I have to rotate in such a manner that this has to come back to its same position in the same direction. So I'll rotate it one time, so I'll get one face. Yes, then I'll rotate it twice, I got one more face. Okay, this is not the face, this is a edge. Okay, so I'll rotate it until I get new face twice, then I'll rotate it again. So now I have got the same face in the same position, so I have rotated it thrice. So here you can draw it in the 2-dimension only. So here we are holding it like this along the solid angle and we are rotating it. So at every 120-degree we are getting a new face. So when we'll get this same face, when we rotate it 3 times, so 3 fold symmetry. Okay, so now we'll move on to one more position of holding the crystal. I'll hold it along the edges. Now this is the face, similar thing. rotate it. Yes, this is again rotate it, rotate it. You'll get one face at the front. Yes, then again rotate it, same face. Okay, so we were holding it like this. One. Okay, here you get the solid angle. This is the face. Okay, so here you get one more face. Yes, so one time, then the second time you get the same face on the same position. So here, okay, so I'm holding it along the edges and I'm rotating it. So this is the face I need. So at every 180 degree I'm getting a new face, and we have two fold symmetry. Clear? I'll repeat it once again. So if there is no form, then no fold of symmetry. Then if we hold it along the faces, we'll get 1, 2, 3 and 4 fold symmetry. Along the solid angles, one face, two face, three, sorry, this is the, okay, along the solid angles, 1, 2 and 3. So three-fold symmetry. And along the edges, this is 1, I'll rotate it. 2, sorry, this is the face, I'm holding it, I'll rotate it once, I'll get one new face, and I'll rotate it twice, I'll get the same face. So here, two-fold symmetry. I hope this is clear. Now next, moving on to the axis of symmetry. So in axis of symmetry, let us again consider a cube. Okay, so these are faces, edges and solid angles. So here I'll draw an axis wherein it cuts the face. Okay, this is the face. I'll draw one axis to the center. This is the face. I'll draw one axis to the center. Okay, this is the face. I'll draw one axis towards the center. So these axes, yes, so these axes, they are equal when they cut the face or when they okay, let me explain it like this. So if I remove this, okay, so if I remove this, so this is one axis. Okay, so this is one axis, it is going like this, and this is the face, and this axis is cutting the face. Similarly like this and like this. Okay, so what's happening here? These axes are cutting the face at a equal distance. So at an equal distance, then we can name it as A1, A2 and A3. So here the condition will be A1 will be equal to A2 will be equal to A3 in the condition of cube. Okay, so if I take a different crystal, let us understand in this case what happens? Okay, so one face is here, draw it to the center. One more face is here, I'll draw it to the center. And one more face is here, I'll draw it to the center. So here these axes, they are different. See, this axis and this axis, they are cutting the faces at a equidistance, but this is cutting at a different length. So here we can name it as A1, A2 and B. So in this condition what happens? A1 is equal to A2 is not equal to B, because B is bit longer when it cuts the face. The axis of B is bit longer compared to A1 and A2. A1 and A2 are cutting the face at a equidistance, but not B. So here we'll write the condition A1 is equal to A2 but not equal to B. In certain case what happens? All the three axes, they don't cut at a equidistance. Okay, so at that time what happens? This will be A, B and C. So here the condition will be A not equal to B not equal to C. Yes, they are cutting at a, all the three axes are cutting the faces at a different positions. Okay, so I hope these basic concepts of crystallography is clear. So in further class we'll discuss more about crystallography. That's all for now. Thank you.